In this example, we will see how our work with quadratic functions can be applied to economics. But first, let's define the revenue of a business as the amount of money that they bring in from sales of their product. It's worth pointing out that revenue does not take into account the cost to make their product. The amount of money that the company keeps is called profit. The profit is the amount of money they bring in, revenue, minus the cost to produce it. But in this example, we're going to stick with revenue. Suppose that the revenue R of a company selling cheap microphones for P dollars is modeled by R of P equals 30P minus P squared. We want to find the maximum revenue that the company can bring in. To get a visualization of the problem, let's look at the graph of R of P. We can see that the maximum value of R is at the vertex. We can see this graphically, but we can also see it algebraically, because our coefficient of P squared, A, is -1, which is less than 0. And we found that the vertex is a maximum if A is negative. So now that we know that the maximum happens at the vertex, let's find the vertex. The p-value of the vertex is given by -b over 2a, where our b here is the coefficient of p is 30, and a, as we said before, is -1. So p is -30 over 2 times -1, which is -30 over -2, which is 15. So we get that the p-value of the vertex is 15. And to find the maximum revenue, we evaluate our revenue function at p equals 15, which gives us 30 times 15 minus 15 squared, which comes to 225. So we can conclude that the maximum revenue is $225 if we sell microphones for $15 each. Even though it's not used to answer our question, it's worth pointing out that our x-intercepts help us interpret our application. Here, if p equals 0, the microphones are free. Then the amount of money we bring in, revenue, is 0. At the other intercept, revenue is 0 again because we charged too much money and no one was willing to buy any.